My name is Sushmita Saluja, currently pursuing MCA from IIPS CAVV. In today's video, I will walk you through the entire explanation of the confusion matrix and all the performance matrices that are derived from it, such as accuracy, precision, recall, F1 score, specificity, sensitivity, and type 1 and type 2 error. To understand these matrices, we first need to understand the concept of confusion matrix. A confusion matrix is a simple table used to measure how well a classification model is performing. It compares the model's predictions with the actual outcomes and shows where the model was right or wrong. It divides prediction into four categories. True positive. The model correctly predicts a positive case. True negative. The model correctly predicts a negative case. False positive. The model predicts positive even though the actual case is negative. That is known as type 1 error. False negative. The model predicts negative even though the actual case is positive. This is known as type 2 error. These four values from the these four values form the basis of all the performance matrices in the machine learning. It is also helps calculate the measures like accuracy, precision, and recall, which give a better idea of performance, especially when the data is imbalanced. Using the confusion matrix, we can calculate multiple important matrices. The first one is accuracy. Accuracy tells us how many predictions the model got correct out of predictions combined. Although accuracy is a popular metric, it can misleading when one class dominates the dataset. For example, if the majority of data belongs to one class, a model may achieve high accuracy simply by predicting that class every time. It can be calculated using the formula accuracy equal to true positive plus true negative upon true positive plus true negative plus false positive plus false negative. Now, the second metric is precision. Precision focuses on how many of the predicted positive cases were actually correct. This is useful when you want to minimize false positives. Examples include spam detection, fraud detection, or any situation where a wrong positive prediction can cause unnecessary alarms. The formula of precision is equal to true positive upon true positive plus false positive. Next we have recall. Recall tells us how many actual positive cases the model was able to correctly detect. High recall is important when missing a positive case is very risky, such as in medical diagnosis. Its formula is recall equal to true positive upon true positive plus false negative. The next metric is F1 score. The F1 score combines precision and recall into a single number. It gives a balanced measure when both false positive and false negative matter. This metric is especially helpful when the dataset is imbalanced. Its formula is F1 score equals to 2 into precision recall upon precision plus recall. Another important metric is specificity. Specificity measures how well the model identifies negative cases. It is also called the true negative rule. Its formula is Specificity equal to true negative upon true negative plus false positive. Finally, we have type 1 and type 2 errors. Type 1 error, false positive, predicting positive when the actual case is negative, which reduces precision. Type 1 errors affects precision for a model which measures the accuracy of positive predictions. Its formula is type 1 error equals to false positive upon false positive plus true negative. Type 2 error, false negative. This occurs when the model fails to predict a positive instance even though it is actually positive. This is also known as false negative. Type 2 errors impact the recall of a model which measures how well the model identifies all actual positive cases. Its formula is false negative upon true positive plus false negative. Example: a diagnostic test is used to detect particular disease in patients. Type 1 error. This occurs when the test predicts a patient has the disease, but the patient is actually healthy. Type 2 error. This occurs when the test predicts the patient is healthy, but the patient actually has the disease. Missing a disease positive patient Missing a disease positive patient can be far more dangerous than raising a false alarm, which is why recall becomes a very crucial matrice in medical cases. Now take the example from the assignment to understand the importance of precision and recall. Now we will solve the question from my assignment. Here we have a table which from we take true positive is equals to 6, true negative is equals to 8, false positive is equals to 2, and false negative is equals to 8. So first we find the accuracy by the formula we have discussed before. So we have the accuracy 7 upon 10. Accuracy measures the overall connections of the model, the proportion of all predictions that are convert. Here 70% predictions are correct. Now we calculate precision by the formula we already have discussed. So the precision is 3 by 4. It measures the quality of the prediction. When the model predicts positive, how often it is correct. Here 75% of the positive predictions are correct. Now we calculate recall by the formula we have learned before. So the recall is 3 by 4. It measures the model's ability to capture all actual positives, that is, what proportion of actual positives are identical. Here only 60% of actual positives are captured. Now let's take the example from the assignment to understand the importance of precision and recall. Suppose we build a cancer detection machine learning model for 100 patients. 10 patients actually have cancer, 90 patients do not have cancer. The model makes the following prediction: true positive is 7, false negative is 3, false positives are 20, true negatives are 70. If we calculate accuracy, we got 77%. At first glance, 77% accuracy looks good, but the model misses 3 cancer patients, which is dangerous. The precision of the model is very low. Only 25% of the people predicted positive actually have cancer. The recall is also concerning because the model detects only 70% of the actual cancer cases. This example clearly proves that accuracy alone can be misleading, especially when dealing with sensitive or imbalanced datasets. To summarize, when accuracy is low, the model fails overall. When precision is low, the model produces many false alarms leading to wasted time, effort, and cost. When recall is low, the model misses actual positive cases, which can be extremely dangerous in fields like cancer diagnosis or fraud detection. Now, the final takeaway from the assignment is the accuracy is not enough to judge a model's performance. Precision and recall together give a much better and deeper understanding, especially in high-risk and imbalanced real-world applications such as fraud detection, medical testing, spam detection, and intrusion detection. So, thank you so much for watching this video. I hope this explanation of the confusion matrix and performance matrices was helpful. If you found this useful, please like